We'll now take a look at how to process two-dimensional arrays. And for the rest of our discussion, we're going to assume that the arrays are not ragged. We can do it with ragged arrays, but just to simplify the discussion, we're just going to assume that they're not. Now, there are three different ways that we can process two-dimensional arrays. We can either process the entire array, we can process a particular row, and this is called row processing, or we can process a particular column, and this is called column processing. We'll use the following example for explaining how to process arrays. So let's say I have a final int rows, which is set to 7, and a final int columns, which is set to 6. I'm going to create a two-dimensional integer array called matrix, where we will have 7 rows and 6 columns, and then we're just going to keep track of a couple of variables. So we'll have a sum variable, a largest variable, and a temp variable. Now, since we have an array of arrays, that means we can process each row and we can process each column as one-dimensional arrays. And well, we've talked about how we can process one-dimensional arrays, right? So if you have forgotten, we can use for loops. Yep, that's right. We're going to be using more for loops for processing these arrays. If we want to initialize all the elements of our array, we can just use a nested for loop. So here's an example where we're initializing all the elements in the array to 10. So the first for loop will take a look at each row of our array, and then the second for loop will take a look at each column. Now notice that when looking at the number of columns, we use matrix I.length instead of matrix 0.length or matrix 1.length. So this code actually lets us process ragged arrays because for each row I, we're getting the length of that particular array. So even though we said earlier we can assume we're not dealing with ragged arrays, this code right here does work for ragged arrays. But the whole point is the outer for loop will take a look at each row, the inner for loop will take a look at each column, and then for each element then we can just set matrix ij to be 10 in this case if we wanted to initialize all of them to 10. To print all of the elements of a two-dimensional array, we can use a similar loop to handle that. The thing is we got to be really careful with our formatting. We have to make sure we get the spacing right. So like for example, maybe I want to print all the elements of one row on one line. And then all the elements on the next row will be on a different line. So we have to make sure that we handle the spacing correctly. So here's our code for that. So we still have our outer for loop that will take a look at each row. And then for each column, we would do a system.out.print method. And notice that we include an additional space. So we print the element and then we concatenate a space. That way there is some spacing between the elements. And then after we process the inner loop and before we end the outer loop, we have this system.out.print line. That way the next set of elements, so the next row, will be printed on a different line. If we need to have the user input values for each element in our array, nested loops are also great for that. So if you haven't noticed, just nested loops is kind of the way we handle two-dimensional arrays. But here's our code for doing that. So our two for loops are the same. So we check each row and then we check each column. And then we just have one line here that lets the user enter in an integer and that gets stored in matrix ij. Now if we want to get the sum of each row, we need to add just a couple more computations when processing the first for loop and we can actually get it. So here is our code for computing the sum of each row. So for each row, we start off by initializing sum to 0. And then we process each column of that row, and we just simply get the sum by taking the element in our matrix. So we do matrix ij, and we just add that into our sum. And then once we're done processing that for loop, that means we've gone through an entire row, and we can just print the result of our sum. So that's what our system.out.println statement here does. It just says that the sum of row I plus 1 is our sum. And the important thing about this is when I go to the next row, I need to reinitialize the sum. I need to set it back to 0 because otherwise I'm going to have the sum from the previous row and then I'm going to be adding more elements to that sum, which I don't want to do. So this is why we do our sum initializing our sum inside our outer for loop. So this allows us to get me the sum of the next row and just keep repeating. So if we want to get the sum of each column, well, the format is going to be very similar to getting the sum by row, except now we have to swap the for loops. So beforehand, we would say for each row, we'll take a look at each column. Now we're going to say for each column, we're going to look at each row. So here's our code. And initially, you take a look at this and you'll see it looks very similar, almost identical to our previous nested for loop. But take a look at our loops a little bit closer. And what you see in this first line is we're using our J, and we're looking at matrix 0.length. So this is having me take a look at the first row. And here is where we're assuming that the two-dimensional array is not ragged. So now we're assuming that each row has the same number of columns. Otherwise, this gets a lot trickier if we were to not make that assumption. So here we're taking a look at each column, and then our inner for loop is looking at each row. So now when I look at matrix ij, I'm looking at matrix 0, 0, and then matrix 1, 0, and then matrix 2, 0, and so forth. Instead of looking at every single column for a row, I'm looking at every single row for a column. But everything else about this stays the same. So I'm still getting my sum, I still print the result, and then when I go to the next column, I still need to reinitialize my sum to 0. If I want to get the largest element in each row, I'm going to use the same nested loops from before, except now we're going to compare the current largest element with the current element. So here's my code. So it looks like it's a little bit more complicated, but when you look at it closely, it doesn't really differ that much. It's just now instead of initializing a sum to 0, we're initializing our largest to the first element of the row. And that makes sense. That way we can just get our initial value. And then we look at each column and we just compare if our current largest is less than the element that we're looking at. And if so, then we're going to update our largest to the new larger value. And then we just output the largest. Then we go to the next row and we reinitialize our largest value and we just repeat this. And then the code for computing the largest element in each column isn't really different. It's just now that we've flip-flopped our for loop. So here's our handling each column, and then our for loop for handling each row. So we're just flip-flop that, and then we just change what our initial largest element is. So it's no longer matrix I0, it's now matrix 0J. But everything else belowhand, so everything here onward, is pretty much the same as before. It's just we now flip-flop our for loops, and we change what our initial element is that we're going to initialize our largest to. The last thing we'll talk about in this lecture are how we treat two-dimensional arrays and parameters. And just like with one-dimensional arrays, we can pass two-dimensional arrays in our methods. We just have to make sure that when we're creating our parameter that we're declaring it as a two-dimensional array. So for example, if I created a method that would print the entries in a matrix, so I can have something like public static void print matrix, my parameter just needs to be a two-dimensional array declaration. So we would have int with 2 square braces instead of just 1 square brace. And notice here, just kind of like with our one-dimensional array, that we don't need to specify the size of either dimension. We don't need to pass the number of rows or the number of columns. We have that information already. We can take advantage of matrix.length and matrix I.length, where I is some arbitrary row. But we can use this information for getting the rows and columns of our two-dimensional array. Now, when we pass it, it needs to be stored somewhere, right? Well, let me take that back actually, because technically we're not copying the array. We're copying the reference variable. But when we create the array in general, how does it actually stored in memory? Well, Java uses a row ordered form because, like I said a while back, when we create this two-dimensional array, we're not having like a two-dimensional table actually being stored in memory. Our main memory is more laid out like an array than anything else. So how do we store a two-dimensional array? We use what's called row order form. And what that simply means is that the first row is going to be stored first, and then we're going to store everything in the second row, and then we're going to do the third row, and then the fourth row, and that's all going to be put together as one giant array. So that's how it's actually stored in memory. Now, as far as your programs are concerned, you don't need to worry about knowing that your two-dimensional array is stored in row order form, but it is still something that's good to know.